So what we're going to talk about today is how to write a system of equations based on a word problem, which is, I know, everybody's favorite thing in the world, because we all love word problems, okay? But we're going to start with some simpler ones, and then we're going to get a little bit more complicated. And as we start with these, we're really just talking about translating from a word problem to an algebraic expression. So remember, before you look at a word problem and think, I don't know how to do this, because I think as soon as people see word problems, they're like, whatever, this must be the hardest thing in the world. Don't think that. Just think again, you're translating it from one language into another, and the other language you're translating it in just happens to be into numbers. So we have two sentences up here. Remember that a system of equations is just multiple equations. So if we have multiple equations, we're going to need multiple sentences to translate. So instead of just taking one, like we might have done before, and just translating this first one, the difference of two numbers is 3, we are going to take both of those sentences, translate them, and make sure they work together. And if they're going to work together, that means both of them have to contain the same variables. So the first thing I want you guys to do when you're deciding how to do these equations is to pick your variables. The easiest variables are usually x and y, because that's what we're familiar with. As we get to the more complicated word problems, we'll talk about how choosing more specific variables can make it a little bit easier because it makes stuff make more sense. Okay, so to begin with, let's take a look at these two sentences. The first one says the difference of two numbers is 3, and the second one says their sum is 13. So the first thing I want to do is pick my variables. So it is, but let's hold that thought for a second, because literally the first thing I want to do is pick my variables. What variables do you guys want to use? Those are numbers. Variables. X and y. All right, so we're going to use x and y. I know it seems like, why do I need to do that step for this one? Just get in the habit. All right, so pick your variables, x and y. My second step is going to be write my equations. So what Jesse said, I don't know if you guys heard him, what Jesse said is when he looked at the first one, he saw what keyword? Difference, which tells you you're going to be doing what? Subtraction. So the difference of two numbers is 3. How would I write that? How would I take that from that sentence and write it as an equation? So I'm going to put this one in green just so we can differentiate. What would be that first equation? X minus y equals 3. Very good. That's my first equation. So that's my green one. All right. And then let's do the black one. It says their sum is 13. So what would be your other equation? X plus y equals 13. All right. So now that's step 2. We've written our equation. Step 3 is going to just be solve the system. And you can solve the system any way you want. Three ways that we've discussed solving are graphing, substitution, and elimination. You might have favorites, you might have ones that you like to use, you might have ones you don't like to use, but based on the way equations are set up, there are going to be ways that are easier and going to be ways that make more sense. So if I take a look at this system, my green and black right here, graphing, substitution, or elimination? Elimination. Why do you look at this and think elimination? And maybe you don't, that's okay, but why would somebody look at this and think elimination? You see that the two y's are opposites, good. And you also see that they're both written in standard form, which means that the x and y are both on the left side, same side, right? So if they're written on the same side, then elimination is probably going to be the right way to go. And this one's going to be really simple to solve by elimination because the y's already are going to do what? Cancel out. How are they going to cancel out? One's negative y and one's positive y, so they just cancel out. I'm going to rewrite them down here in red. X minus y equals 3. X plus y equals 13. What happens with my y's? They cancel out. What happens with these x's? Why is it 2x? Because they both have a 1 in front and they're positive. And that gives me what? 16. Very good. Because these are both positive, so we put them together. And then how do I finish that? Divide by 2. And then x must equal 8. Very good. As a reminder, you guys should be copying this down as I do this, because you're going to need it when you go back to the boards to do your own. Okay? Am I done yet? No, why not? Because there are two variables, so I can't just solve for x. How do I solve for y? Plug it into the black one, the green one, or it doesn't matter? Doesn't matter. I'm going to plug it into the green one because it's on top. So I'm going to plug it in there, and that's going to look like what? 8 minus y equals 3. So you could probably do this mentally, but if I don't want to do it mentally, what would I do? What? If I don't want to do this mentally, how would I solve this? How do I get rid of a positive 8? Minus 8, minus 8. What's 3 minus 8? Negative 5. And then on this side, what do I have? Negative y. If I have a negative y equals negative 5, what does positive y equal? Good, because I divide by negative 1, divide by negative 1. 5 divided by 1 is 5, and it's positive because negative makes a positive. Good. Could you have done that in your head? Yes. You could have said 8 minus what is going to give me 3. Y must be 5. How do I write my answer? 8, comma 5. Okay. You do not always need to write these as an ordered pair because, as we'll see in later examples, if it's not x and y, you're not going to graph it onto a coordinate plane anyway. Okay? So 8, comma 5. Perfect. Great job. I would say the most challenging step here is writing your equations if they're more complicated. All right? If they're more complicated, that's going to be your hardest step. But again, you're just translating. Okay? So you're just translating. So in this one right here, the difference of two numbers is 3. Their sum is 13. First step, identify your variables. What do you want your variables to be? Doesn't matter. X, y is fine in this case. So we're going to use x and y. All right? What about my equations? What would my first equation be? The difference of two numbers is 3. Oh, I'm sorry. We just did this exact one. That is, all those notes should go in those spots. All right. Let's take a look at this one. Find the value of two numbers if their sum is 12 and their difference is 4. So how is this different than the one we just looked at? How is this different than the one we just looked at? Okay, we see sum, all right. And you see difference? I don't see two sentences. David? What? Okay, it tells you the difference and it tells you the sum, but it's only in one sentence. Is that still going to be a system? Yes? How come?
Because sum is the result of an equation.
So sum is the result of an equation and difference is also the result of an equation. So even though it's one sentence, it's kind of a compound sentence, right? So think back to English. What is a compound sentence? Sentence made of like two separate parts, right? So you're putting two separate parts together. So even though this only one sentence, are there two equations in there? What are they? Well, first let's find our variables. So we're still going to use what? X and y. Maybe next time we'll use those. All right, so x and y. Find the value of two numbers if their sum is 12 and their difference is 4. So what are my equations going to be? X plus y equals 12. And we got that from sum is 12, right? And then what's my other one?
X minus y.
Perfect. X minus y equals 4. So even though there's just one sentence, there's two things happening in there. And what are your keywords that tell you that? Sum and difference. All right? So you're seeing two different results words. So Elijah said that sum is the result of an addition problem. I really like that word result. You're seeing two words that give you a result. Okay, what do you think the best way to solve this would be? Elimination again, right? Elimination again, because what happens with those y's? They're gone right away. So what do I end up with? 2x equals 16 again. All right, and then what's that going to give me? Because 1x plus 1x is 2x. So what is x again? All right, and then where am I going to plug that in? Doesn't really matter. Any one you want. Let's do the top one. So that's going to be 8 plus y equals 12. So what does y have to be? Good. Y equals 4.
But is it always going to equal the bottom one?
What do you mean?
Because the answer is 4.
No. That was just a convenient happening? All right, and if this is the right answer, if you plug it in here, it should also work. Is 8 minus 4 equal to 4? Yes, 8 minus 4 equals 4. Yes, so it works for both equations. All right, so those are our systems of equations with word problems. If they're very simple, here's one that's a little bit more complicated. So again, make sure that you are writing this down so you have this example written at the board. All right, let's take a look at this word problem. A restaurant sells chicken tacos for $2.50 and beef tacos for $3. They sell 120 tacos in one day. If they make $320 that day, how many beef tacos did they sell? Okay, so let's back up to the first part. There is a lot going on in this word problem. It's still just two equations, but we have to figure out what they are. But before we can do that, oh, okay. All right, before we can do that, we have to identify our variables. So what do you think our variables are? What are our like two things that we're talking about in this problem? Tacos. What kind? Beef and chicken. So what do you want to use for your variables? You could. I'm not gonna. C and B. Why, Alondra? How did you get into my brain and choose B and C from my brain? C for chicken and B for beef. Could you use M and L? Absolutely. But at the end of the problem, when you're trying to figure out the beef tacos, it's going to be way easier to do if you go back and you're like, oh, B stands for beef. That's the one I need to figure out. So you can use X and Y every single time, but in a word problem like this, which is already complicated, make it a little more idiot-proof, all right? Check your variables and make them make sense. If I'm talking about beef tacos, don't use an X, because then I'm going to go back at the end and be like, wait a minute, was X beef or was C beef or Y beef? Just use B and C. Am I going to mark you wrong if you choose different variables? No, but it just makes it a little less. There's just one less opportunity for error there, okay? So if you can, because I'm the type of person who makes mistakes, if I can't, like, I'm trying to keep track of stuff in my head. I know a lot of you guys love to try to keep track of stuff in your head and do everything mentally. This is going to be a way to make sure you're going to have an easier time keeping track of it, okay? So B and C are our variables. Now, let's look at what is happening in this problem. What's going on in this problem? There's a restaurant that's selling tacos, right? And there are kind of two things that are happening. What is the number 120? Whoa, that was supposed to go underneath it. What is number 120? How many tacos they're selling, right? So they sell beef tacos and they sell chicken tacos, and how many do they sell? 120. So what do you think that equation might be? B plus C equals 120. Because this is literally just the number of tacos they're selling. So B plus C equals 120. Because there's beef tacos and there's chicken tacos, and if you count up the number that they sell, they've sold 120. What's the other piece of information in here? How much money they made, right? They made $320. But I can't just say B plus C equals $320 because why? Why can't I just say B plus C equals $320? Exactly. It's how much money they made by selling the tacos, and do they cost the same amount? They cost something different. So that $320 has to take into account the fact that how much were chicken tacos and how much were beef tacos? $3. So does anybody know how I could write that equation? Okay, 250B, 250C. I'm just going to write it as 2.5. I don't need that other zero, so again, take out stuff you don't need. So 2.5 times C plus 3 times B is going to give me what? 320. All right, so why is this one more complicated than this equation? They both have to equal it without going over. Very good. But also, like, this is just doing what? B plus C equals 120 is just doing what? Literally just counting the pile of tacos that they sold, right? Hopefully they're not just in a, like, not a pile of tacos. Hopefully you're just keeping track, right? But this one here has to take into account the fact that they cost a different amount of money, okay? So that one's going to give you how much money they sold, and this first equation is going to give you just how many tacos. Now we have our equations. How do you want to set it up? How do you want to solve this one? It's definitely a little bit more complicated, but we could graph it. Maybe substitution. We could do elimination on this one too. I would do either substitution or elimination. If you're going to substitute though, what do you have to get by itself here? One of the variables, either C or B. It doesn't really matter which one. So how many people want me to do it substitution, and how many people want to see how to do it with elimination? Substitution? All right, let's do substitution. If we want to go back, we can look at elimination. So before I do substitution, I've got to get a letter by itself. Which variable do you want to get by itself? C. So Elijah, we're going to get C by itself. So B plus C equals 120. How do I get rid of the B? Subtract B, subtract B. These are not like terms, right? So what do I end up with? C equals negative B plus 120. Very good. Could I just write it as 120 minus B also? You can, but again, we keep things in slope-intercept form as much as possible. Okay, so what do I do with this now? I'm not graphing. Nope. I'm doing substitution, so what do I want to do then? Plug it into this equation. What do I take out of this equation? C. And what do I put in wherever I see C? Negative B plus 120. And when I put it in, I put it inside parentheses. So that's going to look like this. 2.5 parentheses, take out the C and plug in negative B plus 120. And then what do I have left? Plus 3B, very good, equals 320. That's a 3. All right, now what? We're almost done. Now what? Distribute the 2.5. So 2.5 times negative B gives me what? Good. Plus 2.5 times 120. 300? Science. Oh man, I'm so good. I still got it, guys. 300 plus 3B equals 320. All right, now finish. We're almost done. What do I do with the 2.5B and the 3B? No. I only have 1 behind the decimal because I made it 2.5 instead of 0.50. So I moved it over once. All right, so what's 2.5 negative? 2.5 plus 3. Positive or negative 0.5? Positive because the 3 is bigger. Good, so 0.5b plus 300 equals 320. And then finish, subtract 300, and you get what? 20 equals 0.5b. How do I finish? Divide by 0.5, divide by 0.5. B is equal to 40. Which part? Don't say all of it because I know it's not all of it. Which part, Jesse? Like the substitution part or the distribution part? Second line right here. So we multiplied everything by 2.5. So when you multiply 2.5 times negative b, that gives you a negative 2.5b. 2.5 times 120 is 300. And then we still have all this stuff over here. So it's just plus 3b equals 320. And then what did we do with these two things? They both have b's, so you can put them together. So negative 2.5 plus 3 gives us 0.5b. All right? Okay, so then you divide by 0.5. Dividing by 0.5 actually increases your number. And so then b equals 40. And then last step, all I have to say is 40 plus c equals 120. Wait, hang on, hold that thought. What does the question ask for?
Beef.
How many beef tacos? Do I even have to do anything? No, I have my answer, right? How many beef tacos were sold? 40. I'm done. All right? So Elijah, I don't know if you thought this, but by Elijah picking C to substitute in, that meant all my C's went away, and so we ended up with B's. So if you're thinking, like, which one should I substitute, that's a good way to do it. Okay, great work. That is a really hard problem. That's a lot going on in there. They're not all going to be as simple as the difference problems, but some of them will be. Some of them will be this complicated. That's why it's really important to do the steps. Picking your variables might seem like a waste of time. It's not, all right? Could you pick X and Y for this one? Absolutely. But then at the end, you'd be like, well, I have my X. Was that beef? Was that chicken? I can't remember. I don't know what to do. You got to go back to the beginning. So pick variables that make sense. And then when you're setting up your equations, remember that if you're just counting, that's just a total. That's going to be the B and the C by itself. But if you're talking about money or time or whatever it is, then you have to multiply by your variables to get your other total. Okay, go try these 3 at your boards. This is all you're going to be doing at your boards, so when I okay it, you guys can put your socks and markers up.